Now I'm going to give you some helpful hints to help you remember these polyatomic ions. First of all, remember when we have the ending ate or ite added in the name, all it means is we've added oxygens, commonly after one of the nonmetals, but we've added oxygens. So I'm having you memorize how many oxygens have been added when it has the ate ending. Then you just work with the rules. If I add the prefix per, becoming perate, that just means I added an additional oxygen. If I go to ite, change from ate to ite, that means I've taken one oxygen away. If I change from ate all the way to hypoite, that means I've taken two oxygens away. So then there was a trend that someone saw on the periodic table to help you remember these. First of all, to help you remember the ate and the ite, how many oxygens are added? Well, if you look on the upper right hand corner of the periodic table, and this is where you need to have your periodic table out and recognize this stuff. So you look at the upper right hand corner of the periodic table, and you see that we've left off fluorine and we've left off oxygen. Fluorine because fluorate is inconsistent. Sometimes it decides to work, sometimes it doesn't. So this person left it off the trend. And secondly, we left off oxygen because we're adding oxygens here. We see that everything in the light green in the upper right hand corner, and it has the ate ending, will add 3 oxygens, such as borate, BO3, carbonate, CO3, nitrate, NO3, chlorate, ClO3, bromate, BrO3, and iodate, IO3. Now remember, the chlorate, bromate, and iodate, all of them in group 17, your halogens, are also called the oxyhalogens. Those are the only 3 that run the extreme from the hypo to the per. Those are only 3. Everyone else stays within the ate and the ite. So if nitrate is NO3, then nitrite is NO2. Now sandwiched between the staircase and the corner of the room, we have those in purple. And those ones have 4 oxygens added to them when they have the ate ending, such as sulfate is SO4, phosphate is PO4. Now if sulfate is SO4, then sulfite is SO3. We just take an oxygen away. Now the other trend that the person saw is not only knowing the number of oxygens to add, but also their charges. Now the nice thing about this, when we take away oxygens or add oxygens, we never change the charge. So once you memorize the charge, you have it for every form. By chance, majority of these polyatomic ions follow the charge of the column. For example, chlorate, bromate, iodate all follow the charge of column 17, which is the -1. Sulfate and seleniate all follow the charge of group 16, which is a -2. Phosphate and arsenate follow the charge of group 15, which is a -3, and silicate follows the charge of group 14, -4. The oddballs are up there at the top row, and that's your nitrate, carbonate, and borate. They do not follow the charge of the actual column. However, they do follow the trend in becoming more negative as you move to the left. So the reason they're offset is because remember, we don't start with fluorate. We don't start with group 16 of oxygen. We don't start counting until we get the nitrate. That's why nitrate's a -1, carbonate is a -2, and borate is a -3. So recognize these on the periodic table. The last helpful hint is the word prefix thio. Just understand this. Whenever thio has been added to a compound, it just means that an oxygen has been replaced by a sulfur. Now both oxygen and sulfur are both in group 16, so once again the charge does not change. Easy one to see this with is with cyanate, OCN-, thiocyanate is SCN-.